Thank you guys so much for having me in general. I believe that I'm the first actual speaker for this club, so it's truly an honor. Kellogg holds a very special place in my heart. My roommate is actually in his first year at Kellogg. His name is Harold. And I've gotten to experience some of the things you guys do, gone to some of the events, kind of walked around campus, and I've begun to live a little bit vicariously through him. So I think the program you have over there is absolutely awesome, and I'm glad I could be a part of it, even in a very little way. So before I start, I want to do a couple pretty shameless plugs. These will definitely not be the last, but they will be the first shameless plugs that I do. So a lot of this content that I create, it goes on YouTube. If you're interested in data science and sports analytics, I would definitely check out my channel. Feel free to connect with me on LinkedIn as well. I'm happy to answer questions offline or as they come to you after this is done. So I would, I'm always welcoming anyone to reach out through that medium. Finally, if you're interested, you should check out my website, which is the third QR code on the top, Playing Numbers. That's where I post a lot of the sports analytics research that I do. It's also a platform where other people can send in articles and research for us to publish it there. So if you're interested in getting into this industry, basically the best way to do that is to produce projects and to produce content. And that is a place where you can share it with a reasonably sized audience. Finally, my Twitter's up here if you'd like to follow me. That's kind of another fun way to connect. And again, part of my passion here is actually sharing this field and sharing information about it, because I think that clarity around it is, there isn't enough. So without further ado, I should probably actually introduce myself here. So my name is Ken, and I'm the Director of Data Science at Scouts Consulting Group. Shane gave me a beautiful introduction, but I feel like I should talk a little bit about more about what my actual work entails. So at Scouts, we help improve the performance of athletes and teams by analyzing the data that's collected on them. So, basically all major sports collect a tremendous amount of data on the players. And if you partner with a team, you're able to, have access to that and to actually create some really unique insights from it that can help improve performance specifically. Now, I think that it makes the most sense for me to give you guys an example of how analytics can have an effect on a game. So let's jump right into that really quickly. Throughout this kind of talk presentation, whatever you want to call it, I'll give you a couple examples. I'll tell you a little bit about my story. And I'll also give you a concrete project that I've done with actually a company that was founded in the garage at Northwestern called Recruitment. So that's kind of a fun way to tie the sports analytics talk back to your community there, because there's some really cool things happening, in your backyard or literally in your, your garage. So my first example comes from this kind of toy example. And if you're a coach, would you rather have Shaq taking 2 free throws or Steph Curry shooting a mid-range jump shot? So if you're not too familiar with basketball, each free throw is worth 1 point. The total amount of points in each of these scenarios you can make is 2. So Steph's shot is worth 2 points. Shaq's 2 free throws are also worth 2 points. A little context here, Shaq is one of the worst free throw shooters of all time. And Steph is arguably the greatest shooter of all time, from anywhere on the court. Now, you guys are all very smart MBA students. I know that, I wouldn't ask a question as silly as this if it didn't have a somewhat surprising answer. So in this scenario, you'd actually much rather have Shaq taking free throws, even though he is one of the worst of all time, because the expected number of points that he scores from taking those free throws is higher than Steph's mid-range jump shot. So again, like the quick numbers here, Shaq is shooting at a little over 50% from the free throw line, and the expected number of points that he's going to make is slightly over 1. Steph, who's actually a very good mid-range jump shooter, is only making those shots at a 48% clip, which is a less than 1 expected point per shot. So again, in this scenario, you'd rather have Shaq, who's an awful free throw shooter, taking free throws. Now, let's take this example a little bit further. What if Steph was to take literally 1 step back? What would this mean for this scenario? So if Steph were to take a step back and he was along basically along the perimeter to take a corner three, this shot is now worth actually 3 points rather than 2 points. And the probability that he actually makes that shot is virtually the same. It might go down by a single percent. Now you can see the number of expected points that he makes on that shot is significantly higher than it was before, and it even usurps, Shaq over here. Again, if we were to have Steph shooting these free throws, he's an 80 to 90% free throw shooter. That's the expected points here for that would be 1.6 to 1.8. So as you can see in this scenario, that mid-range shot, the shot inside of the 3-point line that is not either from, at the free throw line or at the basket, is not at a premium. It's actually a bad shot to take. And there's some negative incentives to do that from a coaching and a scoring perspective. So I think something that really ties this concept together is this visual. This is by Kirk Goldsberry. And he's actually written this book called Sprawl Ball. I highly recommend it. It's one of my favorite books if you're interested in basketball analytics in general. But this graph shows on the left here the quantity of shots taken from different areas on the court in the 2001-2002 season, and then in this most recent season. As you can see, pretty much all of the shot volume has moved outside of the 3-point arc and towards the basket in the paint here. The volume of mid-range shots is, it hasn't gone zero. This is only showing if I believe there's more than like 50, 100 shots here. But this has absolutely changed the face of what basketball looks like. And, this is the power of analytics. The rules have not really changed in this period of time. It's just the information. And, teams are obviously taking notice. You look at the Rockets, the Warriors, where they're changing their style of play to match the positive incentives, to match the expected point values outside of this range. And so what comes with this are a couple things. First, is this even good for the game? You look at one of the most electric players of all time, and obviously the greatest player of all time, Michael Jordan. Some of his most iconic shots were from mid-range. You look at the flu game, you look at some of the clutch shots that he hit, they weren't from outside of the 3-point line. There's like this artistry that he created in that zone. And you're getting rid of that effectively when you're pushing everything towards the perimeter and towards the basket. So, these are the types of questions that we think about when we're analyzing a game in this sense. Now, I'm obviously focused on the performance, so I would love to see pretty much everyone only taking threes and only taking layups where they're going to get fouled and have a chance at an extra point. But, that's not really necessarily what it could be greatest for the game. So I'd love to talk a little bit about my story, how I got into this field, and hopefully I can tie in how there are some relevant skills to actually taking, being successful within this industry. Sorry. Ooh. So I started out, all I wanted to do was play sports. I grew up playing baseball and golf, and anyone who would ask me, I would tell them that I was going to do one of those two things professionally. My parents, my teachers, probably some of my friends would tell you that I was absolutely delusional because my skill probably didn't match the belief that I had in myself. But still, that's what I wanted to do, and that's really what I focused on in high school. Going to college, I did end up playing golf. I played at a small Division I school called Towson in Maryland, and I carried that same philosophy of this is what I'm going to do into that college lifestyle until I took my first economics course. I'm sure that all of you guys have probably taken an economics course. I think it's even one or two are even required in your curriculum. But seeing the world through trends and through this quantitative lens really was an eye-opener for me. I realized that I could actually apply this to my own golf game, and I thought that was like a really fascinating concept. Could I actually improve myself by evaluating my own performance? So I'll kind of go into a couple things that if you're looking to improve your individual golf game, that might help you, through that process. So the first thing is the idea of the greatest, I guess it's the marginal return on your investment. So there's a bunch of different areas of your golf game. You have your driving, basically your chipping, your putting, and your iron game. It gets a little more, you can dive a little bit more into each of those. But you really want to be thinking about where you get the greatest return for the amount of time that you put in. So for professional golfers, in general, they can get the most return for their practice by practicing their iron game. You see the greatest variation in iron performance, and you also see the greatest total amount of strokes gained, which is the main metric they're using from that area of their game. So if I was a professional golfer, I would be actually practicing with my irons and my wedges more than any other part of my golf game. You know, at the amateur level, you're probably actually getting the most return from your chipping and putting, because that's where you can pick up some strokes really quickly. So understanding that concept, I really looked at how many hours I put into each area of my game, and I was able to improve quite a bit in that period. After college, I ended up, I tried to go play some professional golf. I played for 6 or 7 months down in Florida. And another economic concept started to really speak to me, and that was opportunity cost. So while I was down there were a lot of guys that were just so much better than I was. And in order to be able to compete, to get to their level, I thought I'd have to spend 3-4 years just grinding it out every day. And the opportunity cost of that was I couldn't actually really focus on learning more about sports analytics. I couldn't chase some of the other dreams that I had. So I realized that maybe this is something that I had to let go. And I kind of pivoted and decided to go to grad school at Virginia. So the reason I went to Virginia is they had a pretty cool program where I could learn some of the more technical skills. You know, I came out with an economics degree. I didn't have really that strong statistics background. I didn't know how to use SQL or Python or any of these things. And at that program, I was able to go in and pick up some of those skills. Right before I actually went there, I took a quick internship at a company called DraftKings, where they do daily fantasy sports, for those that are not familiar. This is very similar to sports gambling. But once I got there, that really opened my eyes to another branch of sports analytics. So at DraftKings, you're trying to predict outcomes and predict how individual players will perform. My experience with analytics, we're trying to actually improve my game. So there was this kind of paradigm shift around how they looked at sports that was absolutely fascinating to me as well. And I was also introduced to a lot of these tools like SQL or again, Python, R, that again, I had no concept of understanding before that time period. So jumping forward again, I had a great time at Virginia. I highly recommend visiting Charlottesville if you've never been. But I decided to actually kind of stall my sports analytics ambitions and get into consulting, because I thought that was a good way to build out a more generalized skill set to really be able to jump back into this sports analytics after I learned a bit more. This is where I met my roommate, Harold. But I absolutely hated consulting. It wasn't for me. I wasn't, working on the technical stuff as much as I probably would have liked. So I decided to go back and get my master's in computer science. With sports analytics, with data science, with any of these things, I think all of these fields are moving a lot closer to computer science concepts than they are to kind of the business side concepts. So I wanted to jump ship and go all the way to the other side to understand what that was like, so I could hedge myself if that field really went that direction. And around that same time, I actually started working at Scouts Consulting Group. So Scouts was a company. It started as a government contractor. And when I came on board, we actually went out and we won this US Ryder Cup work. So that's our biggest golf client. We support the US Ryder Cup team with quantitative insights, which has been pretty exciting. We worked 2016 and 2018. And we're on the hook for 2020 as well, assuming all goes as planned. Now, this is a long story about myself. I can't help it. I like to talk about myself a little bit. But, I think it's important for understanding what skills are relevant in this field. So the first thing that helped us win a lot of work is having played sports at a high level, having competed, being able to speak the language. I think that that's something that is really important, especially when you're trying to get new clients. All of the people that are on our team related to golf at Scouts are under 5 handicaps, I think. And there's a certain amount of respect which does come with that. And I think that that's with anything and with any business, if you have that subject area expertise, you're familiar with how the practices work in that industry, that can really carry you a very long way. The second thing is the technical skills. Without the computer science and I did concentrate in machine learning and AI in that degree. I wouldn't be able to do, most of the analysis that I do now. Frankly, Excel is not a powerful enough tool to be able to create a lot of the insights that we do. And so being able to learn programming, even at the most basic level, or understanding how to talk about programming and understanding how to talk about a lot of the models that we use is extremely, extremely important. The last thing that I took away from consulting and from my days at Virginia is how important the communication with these players and within the industry, well, just how important communication in general is. So we're talking to athletes, we're talking to a bunch of different stakeholders, and the way you actually tell a story is very important for them to actually get buy-in. And I'd love to talk a little bit more about that in this next slide here, because a lot of the work that we do in sports analytics is very similar to analytics in any other industry. You want to talk about agriculture, or you want to talk about finance, whatever it may be. You're using a lot of the same tools and a lot of the same models, but sports is a little bit different in 3 different ways. So the first way, if we're looking at Patrick Reed here, is that a lot of the information, a lot of the things that you're researching are very hush-hush. It's very privatized. Each individual team, each individual player, they get an advantage from the data that they have and from the specific way that it's analyzed. So it is, somewhat of their competitive advantage. And they don't want to share that. In the early stages, when like sabermetrics were getting big, which is baseball analytics, a lot of people thought that there was just going to be this huge open source, first coming of analytics in general. And that actually never happened. A lot of the teams came in and scooped up the best guys, made them sign a bunch of NDAs. Very much, I'm not saying I'm one of the best guys, but I did have to sign some NDAs. And they bring everything in-house. Well, same with the data. The data is not open source. A lot of sports data is completely privatized. The stuff we use for golf, which is ShotLink, the stuff we use for basketball, which is called Second Spectrum, those are all paid data sources, and they're not available to the public, which for a lot of people, they're like, that's crazy. They can get so many cool insights from that data. But on the other hand, there's a ton of money in that secrecy or in limiting the amount of data that's available to certain people. The second thing in sports, which is interesting, is again, how you communicate to different people. A lot of the times we're talking to players or coaches, and they're brilliant. They're great at what they do, but they speak in a completely different vernacular than I do as a data scientist. So I have to go about, I have to figure out how to explain what a regression is or a Monte Carlo simulation is to a coach or a player who's had no prior experience to understanding that. Even the visuals you use, like a bar chart might not even be intuitive, but like a radar chart that you see in NBA 2K might like immediately resonate with everyone because, what basketball player hasn't played 2K? So I think that's a very unique aspect of this specific industry, but it's no different. Well, I guess it is, and it's not different from other industries. If you can speak the language of whatever industry you're in, that's really going to take you far, and that's going to separate you from the pack there. The last thing is, largely because of how secretive information is that you see a lot of teams, there's a lot of diversity in how advanced the analytics programs are at different teams. So you'll see some teams, again, I use the Rockets and the Golden State Warriors as prime examples of being really far ahead with their analytics teams. And then you see other teams that are really falling behind. I think a good example of that from my perspective is my hometown, Washington Redskins, where, with some of the organization that they have there, I don't think that they'll ever be able to compete because the decision-making is not quantitatively focused. So you see this huge divide, and going forward, I think there's going to be even more of a divide. I think that analytics are going to be the difference maker for a lot of teams, a lot of organizations to determine whether they're successful or not. So you look at football, for an example. If you're looking at the draft, it's actually not a good thing to draft a high pick. You should, if you have a really good pick, you should almost always trade them for multiple lower round picks, because the probability that someone gets injured in football or that a high round pick is a flop is extremely high. And in addition to that, you have just so many players on the field that one individual player doesn't make that much of a difference. So you should basically never sell your soul. And a great example of someone who does this is the Patriots. So they're notorious for, winning late, and that's largely because of late in the draft, and that's largely because of the volume that they're looking through, rather than trying to pick off these, great players coming out of college. They're taking a actually quantitatively focused strategy that's really paid off for them. So I think that in addition to that, tradition related to sports is something that is pushing against analytics, and those things are always at odds. You have this kind of scouting versus analytics paradigm in baseball where they're always butting heads. But in a little bit, I'll talk about how I think you can really get past that. So aside from my work, how is sports analytics, shown across the entire industry? So the first place where you really see sports analytics be implemented is what I've been talking about, working with a team. So the first side of the team is the performance. You actually want to improve the performance of your individual players. You want to improve how they work together as a team. And the end goal is winning games, winning a championship, and whatever you do. The other side of working for a team is on the business side and optimizing, for example, ticket prices. How do you get as many people in seats as possible? How do you optimize the food selection, all those things? It's a ton of data that's being used there. The next place where you really see analytics is in the media. So the media, rather than trying to improve performance, they're looking to tell a good story. There's a lot of exploratory data analysis. They're trying to weave a narrative around the sport to make it more interesting to fans. And again, that's like a completely different way of using analytics in this scenario. The third way is in daily fantasy sports over here. So we have sports gambling, we have daily fantasy, regular fantasy sports. And in this scenario, you're trying to predict the outcomes, just like what we were at DraftKings. And that's something that is, again, different from trying to tell a good story and trying to improve performance. So in each of these different subfields, you're getting a different use for analytics in general, and using very different models, which I think is pretty fascinating. The final way is down here in the right corner, is having tools that complement these other industries. So you have tools for individual coaches and players, you have tools for the media, and you have tools that can help sports gamblers. So again, a good example of this is actually Recruitment, the company out of the garage at Northwestern. So they provide a lot of data and information to college football coaches and the college football recruiting departments, so they can make better decisions about how to actually recruit players, which I think is fascinating. So this started for the Northwestern football team. So they built a model that would, provide a prediction on the expected probability that a player would accept their offer and commit to Northwestern. And they've scaled that now into a huge company where they actually, they aggregate all this information for over 50 NCAA football programs. So, the biggest schools are using it. I have a map of that later, but that's one way where you can actually supply information and data and analysis to this coaching department here. So where is sports analytics actually going? So I've talked about, where it's applied, but where is the future of this field? So you're probably wondering what a chess game has to do with sports. Some would argue that chess is a sport, but we're not going to get into the semantics here. So this is one of the most famous chess matches of all time, where Garry Kasparov, arguably one of the greatest chess grandmasters of all time, is playing IBM's Deep Blue computer. And I believe in this specific one, Deep Blue won. And since then, a human has never really been able to compete with a chess AI on equal footing ever again. AI has gone so much further. They're able to beat people in Go and in video games, whatever it may be. But, one thing that is interesting in this scenario is that even though Deep Blue was able to beat Kasparov, if Kasparov was to play alongside another AI where he could, check the moves and make sure and have veto power, a grandmaster paired with an AI can reliably beat another AI. Now, we're not really seeing computers playing against humans in sports ever, but what you can see is that when an AI or machine learning is used in tandem with human intuition, gut instinct, whatever you want to call it, they can really outperform just analytics in general. So a good and also terrible example of this is the Astros in baseball. And obviously there was this huge cheating scandal with them, but a while ago I read this book called Astro Ball that kind of profiles how they use analytics in their organization. And the one thing I took away is how they do scouting. So they let their scouts scout how you normally would, using their gut, looking at how fast they throw it, looking to see if they have it factor. But they do two very specific things that are extremely unique to them. So the first is they give their scouts feedback. So they've created, they basically can tell the scouts if they've made good picks or bad picks, or their decision making was flawed. And they go in, and you're treating the scouts like they're a model in and of themselves. You're training them to improve their performance, which I think is fascinating. The second thing is that they take the scouts' qualitative insights and they feed it into their models. So they're actually taking the gut instinct, and they're able to quantify that in a sense by running it into whatever machine learning processes and tools that they're using. So I think the future of sports analytics in general is tying these two things in tandem. Right now, again, there's this, the gut feeling, the coaching ability, the instinct is constantly combating the analytics. But if these two things can work together, you'll have teams that are absolutely outperforming anyone else in this field. So hopefully in our work, we're able to start that conversation and be able to begin this process of this kind of human machine teaming. But that's yet to be seen. We'll see if some of the organizations and teams that we work with really keep their winning trends going, especially as long as we're integrating this as much as possible. So I wanted to give you guys a concrete example here of what one of these engagements, what one of these projects looks like. So I wanted to give you guys, again, this concrete understanding of what one of these projects is like. Recruit has over 50 Division I football programs that they're working with. Again, this was started out of the garage with Northwestern completely in mind, and it's been able to scale really far. So I met Ben, we just kind of, I found Recruit online, I sent him an email, and I ended up doing a contract for them. So the nature of this project, as I'd mentioned before, is that Ben had built a model that would predict the probability that a player would come to Northwestern. Now, that model worked really well for Northwestern, but it didn't generalize to other schools that well. So Ben hired me on to actually build this model that scaled to all other schools. So you could say, okay, I am the director of scouting at Alabama. I have these 4 kids. What are the probability they come to my school versus any other school that they have an offer from? So the real question is, can we give these coaches, these recruiters, a better idea about if their prospects will actually commit to their school? So again, I'm a college coach. I give out a bunch of different offers to players. Those players can accept the offer and commit to my school, and that's relatively binding. But sending out offers, recruiting kids is extremely, extremely time consuming. You have to fly out and see them. You bring them on for visits. It's a very in-depth process. And if coaches can make better decisions about who they give offers to, who they recruit, they can save a lot of time and a lot of money. So in order to build a model like this is kind of the general data science life cycle. But this is something we go through on almost every project. So first, we collect data, and at Recruit, they have a really good database infrastructure. So we're taking in Twitter data, we're taking in offer data, we're taking in data about where these kids live, how far they are from the schools, a lot of really interesting information that the guys at Recruit have done an incredible job of aggregating. The next thing, we have to make this data actually usable for our models. So a lot of people call this either like ETL, extract, transform, load, or just data manipulation in general. But we need our data to work comfortably with our models and the exploratory tools we're using. So next, we do a lot of data exploration. This can be in the form of pivot tables. You can use Tableau, Power BI, just to understand the correlation between the variables, what might be relevant to actually feed in. Next, we go in, we build an actual model. And in this sense, this is where these types of projects can go a couple different directions. So in this case, we're building a tool, we're putting something into production, but other projects might be just seeking insight about this field, or might be for a one-off decision to be made. So this we're planning to use and recycle over and over again. Another scenario might be if we're a sports team and we're trying to figure out who we should draft, we're only going to use that analysis once. So that's kind of where that could deviate from this visual here. After building a model, and I'll talk about some of the models that we used, we start with user feedback. And I actually think that this is one of the most important, if not most important things that you can have in a model. So you want your model to accurately represent the real world. And in this case, at Zcrew, we were able to get real college football recruiters, real people who had worked in the industry to see if our model was doing anything wonky. And that feedback, we were actually able to guess a little better than some of these coaches and recruiters were, which is pretty shocking. So, the model, the feedback, it doesn't stop here. Even when we have our current model, for anything that you put into production, for any model that you build, you have to keep it up to date. You have to retrain it. You have to make sure that the data is current, because a lot can change in a very short amount of time, especially in sports. So, this is probably maybe like a teaching moment in any analytics that you do. The moment you stop training your model or retraining your model is the moment when things really can start to go wrong. So I definitely would make sure that, you file this away, because the really bad things that happen with data science, the big mistakes that I've seen made, happen when the feedback stops and your model is just kind of running willy-nilly. So let's talk about some of the results here. So we tried a couple different models. The three main ones were a logistic regression, a random forest, and a gradient boosted forest. So I think whenever you're trying to create a probability distribution, logistic regression makes a ton of sense. I'm not sure how familiar you guys are with these models. I mean, for the most part, they're pretty basic. And if you've taken any of the analytics courses, I would imagine you have some familiarity. We run a logistic regression, though, to be able to understand basically a lot about we run the logistic regression because of its interpretability. So logistic regression, just like any other linear model or most other linear models, gives you coefficients, and you can actually see how much each feature impacts the commit probability or whatever that might be. Next, we used a random forest. A random forest or gradient boosted forests, usually, especially in sets like this that have a lot of sparsity, perform really well. And it turned out for this use case, a random forest in general actually outperformed everything else, which I was kind of surprised about. Usually gradient boosted forests kind of trump there, but with our tuning, with our parameters, we were able to get really good results with this one. What we found is that this model had a 93% accuracy in validation sets, and also in our testing. But I'd like to talk about accuracy in general, because I think that this is a really poor way to evaluate this question. So in general, accuracy means the times we got if they committed to the school or did not commit to the school correct. So if an individual player has 50 offers and they don't accept any of them, our model says that they reject all the offers and don't commit anywhere, that model has a 90% accuracy. If our model just doesn't say that anyone goes anywhere, our model would be like 95% accurate. That to me is an awful model because it's not doing what it's supposed to be doing. So the actual metric that we're using for this data is recall. And that's the number of times we guessed that they would go to a place correctly divided by the number of total commits that are out there. So we're getting our recall at around 50%, which is extremely high. So an example of that would be if, just raw probability of guessing a person that has 20 commits, 20 offers correct is 1 in 20. We are trimming that probability down to being able to guess each player which specific school they would go to correctly 50% of the time. So I think that, here we want to make sure we're using the right tools, the right evaluation criteria, because accuracy, some of the other metrics you're using can be a fallacy, can not be representative of what you want to understand. So, Ben over at Zcruit, they're working on integrating this now. This was an awesome project that really hits close to home with Northwestern. So I hope that maybe this process, the understanding of this field was valuable to you. That's pretty much it that I have on my agenda. So I'd love to take any questions if you guys have them. Happy to talk about my work a little bit more. Happy to talk about sports analytics in general, or if you just want to ask me questions, feel free to shoot.
My name is Ben. I graduated from Northwestern as an undergrad in 2017. And I started working for the Northwestern football team the start of my freshman year of college, so 2013. Did that for about 2 years, and then came upon the idea for Zcruit my sophomore year of college, towards in the spring of my sophomore year of college, so 2015. Got together with 3 undergrads while at Northwestern, and we started putting some things together. And by the summer after our senior year, we were working with 13 Division I football programs, including including Clemson, USC, and Notre Dame. So went full-time on Zcruit after I graduated in 2017, and have been doing that since. So about 5 years into working on it, and got together with Ken. I don't know how long ago it was at this point, but around this idea of having a model that could accurately predict where exactly a recruit was going to commit to based on a wide data set that we had, and have been really excited about what where we've gotten this to, and excited to implement this into the product that we have here to help college football programs in the recruiting process.
Yeah, I know Ben's a humble guy. I think Zcruit was the first company out of the garage to get bought, correct?
Yeah, we got fortunate there. So I started working on this, and then the garage opened up with the Northwestern's Entrepreneurship Center a couple months after I started on this, and then we got acquired by the world's largest college sports recruiting company a couple months after I graduated from Northwestern. So we've now been working on growing Zcruit within the framework of this larger company called Reigning Champs that has a headquarters actually in Chicago. So I've been working on it that way.